In this video, AOC will walk you through the steps required to create a high-quality composite tool using the open mold hand layup tooling process. Open mold tooling is a composite manufacturing process. We will be demonstrating the hand layup method, where sheets of fiberglass are layered onto a tool and impregnated with resin. Because of simplicity and cost-effectiveness, open mold tooling is the most common tooling manufacturing process. Before beginning the tool building process, it is critical to have a master model that is in good condition to ensure tools will have the surface finish needed to build quality parts. In addition to the master model, you will also need the following materials: glass reinforcement, 2 different colors of gel coat or a gel coat and a barrier coat, resin formulation, catalyst. Additional consumables: brushes and rollers, balsa wood core or foam core, optional. Before starting work on the tool, we recommend creating a test panel. This will lay the groundwork for optimal glass ply, resin wet out, and surface finish quality. Start preparing your master model by applying a complete mold release system to ensure the mold releases from the master cleanly after curing. The next step in the process is to apply the gel coat to the master model. Start by preparing the gel coat. Mix it with the catalyst according to the product specifications. Apply the first layer of gel coat. Spray with long, even, vertical and horizontal passes with 50% overlapping strokes, building the thickness with multiple passes. The total thickness of the wet gel coat should be 20 mils, which can be confirmed with a mil gauge. Inspect for full cure before applying the second gel coat layer. If you find uncured or wet areas, allow more time or remove and reapply the layer. Once the first layer is cured, you'll then apply a second layer of a different color gel coat, or alternatively, a barrier coat if extra protection is needed for the tool. Ensure the second layer is also applied at 20 mils thick. Using 2 layers with different colors allows for visually tracking wear on the tool, signaling when rework or polishing may be needed. A skin coat can help detect air bubbles and offers a durable and repairable mold surface, which may extend the life of the tool. When a skin coat is selected, begin by applying 1 to 2 ply of 1.5 ounce chopped strand mat. Before adding the catalyst to your resin, be mindful of the activation time so the resin doesn't start to cure while it's being applied. Other factors that influence cure time include catalyst level, room temperature fluctuations, airflow, resin mass sensitivity, and humidity. Load the glass reinforcement onto the tool. Carefully position the glass according to your tool design and wet out the resin with a roller or brush. This will ensure that the resin is evenly distributed and remove trapped air bubbles and excess resin, strengthening the tool as it dries. Multiple layers of glass will be needed. The number of layers will depend on how thick the finished tool should be. Each layer will consist of 3 to 5 ply 1.5 ounce fiberglass, with ply thickness depending on the resin gel time selected. Build the laminate thickness by adding more layers of glass to the tool and rolling the resin on. The resin will heat up as it cures, so it's important to wait for each layer to cool before applying the next layer of 3 to 5 ply. Continue layering until the maximum thickness is reached. Over time, the tool should turn completely white, indicating the process was successful. Depending on conditions and gel times, the lapse time between layering is approximately 1.5 to 3 hours. After the third layer, an optional balsa wood or foam core can be applied for additional stability. The next step is to apply a frame to the back side of the tool. To reduce torsion during the demolding process, we recommend applying a solid frame around the tool. Secure the frame at multiple points using adhesive and laminate for stability. Finally, it's time to demold the tool. Using wedges, work around the perimeter and pull the tool off the master model. With the tool now demolded and inspected, your composite tool is ready for use or additional processing. Thank you for watching this AOC training video on the open mold tooling process. For more details on AOC's different tooling systems and gel coats, as well as a detailed step-by-step guide on building tools, visit our website.